งั้นอินเทอร์เน็ตผมไม่ค่อยดีโอเค Hello
Hello.
Okay. Yeah. Please wait a couple minutes. So let me check. Yeah. Yeah. I think we live on X and Facebook. Okay. So yep. I think we should wait around a couple minutes. Wait
Okay.
more the people to join. Yeah, I think today is very special topic. This is first time to we talk about one of the layer one chain from Thailand.
Yes. And this KUB Chain.
Yeah. Yeah. Hi. Hello. Good morning. Good afternoon. Good evening.
Okay.
So yeah, as I mentioned before, today is very special because this is first time we have talked about one of the layer one ecosystem from the Thailand market. Today we talk about the big cup. Today we talk about the cup chain. Cup chain, uh, cup chain is layer one from the big cup exchange, the biggest exchange in Thailand. I think this is the number one exchange in Thai market. They already have more than 5 million. The user already do KYC on their platform. Yep, and I think I'm very excited to see what they have for the cup chain. And yep. So I think we are ready. Phil. I think
Okay.
we should go.
Okay. So, like Jan Paul say, so what we are going to talk about today is KUB Chain, right? And KUB Chain is the layer one blockchain from BitCup, which is the um, crypto exchange in Thailand, right? So if you guys want to explore more on the BitCup, uh, I mean on KUB Chain after this live lecture, you can go to X and search on this, X handle to explore news on the KUB Chain, right? And but what we are going to focus today, like the live lecture say, like it's going to be the consensus. So why is that? The This one is the table comparison between the KUB Chain, Ethereum, and Huobi from the KUB Chain technical paper, like. And as you can see, the execution engine is also the e, EVM, which is the same as Ethereum and other popular chain. Like, so we don't have to forget about this because I think you guys already know what it EVM like. So for end user, if it is EVM compatible, you can just use MetaMask or Lappy to interact with the chain. And after that, we have the transaction per block and the block time, right? And sorry, I just recovered from COVID-19, so I may cause quite a lot. So as for the block time and the transaction per block, like it's just the hyper parameter that the chain owner can tune. Like, so the more transaction per block you have, the more transaction you can add into the block. And the lower the block time you have, like the lower the latency between block. Like, so if you send transaction to the chain, like, and if the block time is quite low, so you have to wait only a couple of seconds before it can be finalized. So this one, it just the it's just the lay, the high hyperparameter that the chain owner can tune. So nothing interesting about that. Like, and as you can see, yeah, it's quite obvious that the to to put is quite higher than the Ethereum. Like, but um, this one is, it's quite complex parameter to for you to do the comparison. Like, because for example, if you're trying to compare this parameter with Sui, for example, like, so we have a special kind of transaction where you can bundle many transactions into, like, compress it into one single transaction. I'm not quite sure what kind of the name of that transaction in, in Sui, but the point is that if you trying to compare it, it like that, some kind of blockchain have some kind of optimization to be able to add or compress many transaction to accommodate more transaction into one block, right? So it is not going to be fair to compare the transaction per block from the different blockchain, and also from the different execution engine, like, and because all of this parameter is quite trivial to understand. So, like, outer life fracture, what we are going to focus today is only to be on the consensus protocol, like, and add a note, like, all of the information of this life fracture, I get it from the technical paper from KUB Chain. Like, if you guys want to explore more after this live lecture, you can visit the KUB Chain website and then explore the technical paper by yourself. Now, from the KUB Chain, from the KUB Chain technical paper, it said that KUB Chain is a fork from Ethereum based block blockchain, right? But I think what it means is that it is the EVM compatible, and also you may think that because it is a fork of Ethereum, like, you may think of what we are going to talk about today is a Casper FFG that we have discussed in the Ethereum live fracture. Like, so it may have checkpoint, slot, epoch, finalization rule, forks, some stuff like that, but this the whole of it is quiet to complex, and KUB is not going to use that. And why it is complex? Because if you remember, like, in the Ethereum, it have like million of node or hundred of thousand of node. Like, so the consensus protocol have to be complex. If not, it's going to be too slow. Like, and but as for the KUB chain, it doesn't need to go to that ex- extent, like, so this one is going to be too hard, and KUB Chain have it on consensus protocol. And as you guys will see in this live lecture, the KUB Chain consensus is quite simple compared to the outer consensus protocol that we have discussed so far, like the Monet BFT, Tendermint consensus protocol, some stuff like that. KUB Chain is quite simple and easier to understand. And I think for those you guys who doesn't have like heavy background or like the knowledge in crypto that much, I think this one is quite easy, and I hope you guys can follow. Like, and the KUB chain, like, so it is similar to outer consensus protocol. So you have a pool of stake, like, you have a lot of nodes, and then for each block, one of the node get chosen as the proposer, like, who propose a block, like, receive transaction from user packet into a block and then broadcast block to all of the validator in the network. Like and KUB Chain also follow this kind of structure, but it's quite simpler and you will see why. So the step is that first um, a validator set like one of them is chosen as a proposer and create a block and then propose a block. Like so so propose a block means that it just sign the block and then broadcast it to outer validator. Right? So it just broadcast to outer validator in the network. And once outer validator receive a block, like it just have to check that the block is valid. And if it valid, it can finalize immediately and then that is all. You just move to the next box. Like but I think you guys if you follow our live lecture so far, like outer consensus protocol, if you remember we have a proposer, it have to create a block and then broadcast block to all outer validator. Like for Bitcup, it end here. I mean for KUB Chain, it end here. Like but outer consensus protocol, what it requires that validator have to make a vote and then aggregate it into something like certificate and then broadcast again and then vote again before you can finally finalize a block. Like but for the KUB Chain, it end here. So I think some of you guys can guess this one can be quiet that like the last, but in the in the next slide, I will show you that KUB Chain introduce some variable to solve this. Like so, in this case, it's quite dangerous because the proposer just propose block to all of the validator, and then if it was valid, they just finalize it. Like and that is the end. But if you remember, for example, if this one is a proposer and this guy a validator, like what if this malicious or bad proposer send conflict block? Like so in this case it can create a flaw like and can by violate safety. Like so if you guys want to build your own chain, I mean from scratch, for example, you should consider this scenario as well, like where the proposer broadcast the conflicting block and can create a fault, like so it can violate the safety. But for KUB Chain, it introduced a special kind of node to solve this, like which is the official node. Like and the official node is a special node that have the official node is a special node that have the authority to keep the chain moving and punish outer validator if those validator are bad validator or malicious validator. Okay, so if you get into this case, for example, the validator sending conflicting block, so the official node can kick in and then slash this guy, like and may use some recovery algorithm, for example, trying to reconcile with these two nodes that get the conflicting block and the send a block that make the whole network consistent. Like so that is the so that is whyครับchain have to introduce the official node. Like and as you can see in this slide, there are three type of node in KUB Chain. The first one is the validator node, like just like outer validator in proof of stake blockchain. Like the validator node just have to stake their coin, stake their cup, or stake their asset to secure the KUB Chain. Like and then they have the voting power according to the how many cup they are staked, like, and it have the word pool here. I think it is because the validator node can receive delegation from the user. Like, so just like outer proof of stake, I mean the dedicated proof of stake block, blockchain, like where you as an end user can come in if you have a token, like you can dedicate your token to the validator that you like, and then they will gain your um, and it will gain the power according to how many users stake or they dedicate to them, as well as its own stake as well. Like, the next one is the solo node. The solo node is the same as the validator node, except that it does not accept the dedication. So it means that user cannot dedicate to the solo node, like, and it power come only from the its own stake get cup. Like, and the last one that we have discussed it already, if the is the official node. It is the same as validator node. It just have the authority to punish outer validator if it misbehave, or like if it a bad node. Like, and also if some node, like when it is their turn to propose a block and it have not proposed it, so it can make the chain stuck, the official node also come in, like, and trying to propose a block instead of that bad node, like to make sure that the chain can move forward. Oh, okay. Uh, this is clear so far. I think it's quite simple at this point.
Yes, for me it's clear so far.
Yeah,
Okay.
I think I'm pretty clear. But uh, one thing I need to confirm from the KUB Chain, look like they very basic concept, right? Uh, any validator can be like the proposer to send the new block to the author validator, and if the block, if they don't have any conflict, and
Mhm.
they can move to the new block, right?
Yes.
But by the way, they have like the official node to uh, take the control to ensure the all of the network will be healthy.
Yeah. Yeah. You can think it's like that. In my opinion, it's like the police that oversee all of the node. Like, if some node misbehave, the police just get in and then use some gun or use the some something to hit at you, or or jail you, some stuff like that.
Okay, got it.
Okay, so now we already know this the type of the validator node in KUB chain. Like, so what we are going to discuss next is going to be the consensus itself. Like, so what we gonna have to understand is that you're gonna have to understand the process that the proposal get chosen, like, and then after that this proposal will send bulk to all of outer validators. So we are going to dive into how a bulk proposal is chosen. Okay, so it is quite simple. So the process is that, let me delete it. Okay, you have a block from block 0 to block 99, for example, and the chain is going to move from block 0, and then, like, after 5 seconds, it moves to block 1, after 5 seconds, it to block 2, so on and so forth. Like, now, what we want is that given a set of variator, like, we want to assign this variator and assigning them who is going to propose block 0, who is going to propose block 1, who is going to propose block 2, so on and so forth. Right? And that is the the idea. Like, so you just want to assign node in a network to which block they have to propose. Like, and in KUB chain, um, the process of assigning node to be a proposer is have the period called span. Like, and in KUB chain, it use the span of 50. So what do you mean that every 50 block you are going to do like the assigning process periodically every 50 block. Like, so why 50 block? Like, so what what do I mean is that once you do the assigning process, like if you want to assign validator to be the proposer, you're going to assign them one time of the assigning. You're going to assign them from 50 blocks. Like, so this one is one span. So when you are moving to the next span, like you are going to do the assigning again and 50 blocks again. So why you have to do is periodically. Like, the lesson is quite simple. So if you have T node in the network at first, and if you assigning them from block 0 to block infinity, for example, everybody going to get assigned node 1, node 2, node 3, node 1, node 2, and so on and so forth. But what if new validator joining it along the way? Like, but the block are already occupied, or like it already assigned to block 1, 2, 3, 4, 1, 2, 3. So the new node is not going to be able to join and become the proposer. So by doing it periodically, once you are in this span, like a new node joining it, node T already exists. So node 4, node 5, and node 6. So once this span is in, like, so when this span in, you can run the assigning process again, and then this block 4, 5, and 6 also have a chance to get selected as the block proposer. So that is all. Like, so it is that you run the assigning process every period of 50 block.
Only they have fixed the number only the 50 block or any the parameter to maybe sometime the 50 block, sometime it's 60 block or 70 block, or they
I
fix
think it
only the
is. I think they fix at 50 blocks.
okay and
According to the technical
okay
paper.
okay
Uh-huh.
but at the parameter they at the parameter the network can have around 150 validator, right?
Yeah. So yeah, they have at more 151, including the official node. So not all of the validator going to be assigned like in this one span. But when you move to the next span, you have a chance to join.
Okay. Does it mean this is the every validator any validator has an equal chance of the becoming the block proposer?
Not every validator have the same chance. I will explain it in the next slide.
Okay.
But the idea is quite the same with the outer proof of stake. Like, so the more you stake, the more power you have, the more chance you get
Okay,
to
got
be
it.
able to propose.
They decision by the delegation power.
Yeah.
Okay, yeah, all clear. Thank you.
Okay. So now we know about the span. Like, so it is just the period where the validator get assigned as the proposer. So the next question is when you choose do the assigning process. Like, so maybe some of you may think once the first span in, like n at block 49, you can run the assigning process. And once you run the assigning process, it means that it will determine which variator going to be processor for the block 50 to block 99. Like. But the problem is that from block 49 to block 40, you have only 5 seconds. Like. So if you run the assigning process here, the next variator here, like if this span only have 1, 2, 3, like that are processor and the node 5, 4, 5, 6 just joining it between this. Like so maybe this block 50 when you run the assigning process, the variator for get assigned here. Like but once you go from this block to this block, like so this means that the variator for become the processor and it have only allow not 5 seconds, less than 5 seconds to prepare itself for the upcoming span and the upcoming block. So it is not going to be efficient at all. Like so, in KUB Chain is quite simple. So what they do is that they run the assigning process at the middle of the current span. Like so, if the current span is from block 0 to block 49, like the span of 50 block, it is going to run the variator selection or the assigning process at block 26 to determine who are going to be the processor for block 50 to block 99. And for the second span at block 76, it is going to run the assigning process to assign the processor for block 100 to block 149. And that is all the process of I mean when you should trigger the assigning process. Like. And next, now we know when to assign the processor. Like so, now we are going to look at how it assign the processor. Like so, how as I discussed, as I just explained it before. Like so, the more you stake and the more list you have, like it means that you should have the higher chance to propose a block. Like so, in this case, in KUB Chain, like the more you stake, the more power you have, the higher the chance you are going to be the proposer. So how the chance can be determined by the staked KUB. Like so, it's quite simple in KUB Chain. Assume that node 1 have staked KUB of 100, the node 2 have 50, and the node 3 have 25. Like so, what we are going to do next is that we are going to map the staked KUB to the number range. At first, we have 100 staked KUB. Like it's going to map to number 1 to 100. Like so, there are 100 number here, and after that node 2 have 50. Like so, following 100, it's going to be 100 and 1, and you need 50 number here. Like so, it is going to running from 101 to 150. The next one is 25. It's going to start from 151 because this one is 150 and run from 151 to 175. So I think you guys can already guess what's going to happen is that this number ranging from 1 to 175, right? So if you randomly pick number from 1, if you randomly pick number from this range 100 to 175, the chance that it land into this range like is going to be 100 divided by 175. This one is going to be 50 divided by 155, and this one is 25 divided by 175. Like, so this guy have the more stake get cup and have the highest chance to be chosen as the proposer. Like, this guy have the lowest chance being chosen as the one. Like, if this one is not clear, like, so now you just need to remember the number range from 1 to 175. Like, and then what we are going to do is that we have to assign validator into this 50 slot. Like, what you need to do is that you just need to randomly generate 50 random number that range from 1 to 175. And assume that you get this number between 1 and 175. And then you just use the table that we just discussed previously. And you are going to use the random number here and map with this table. Okay, so for the first one, the random number is 105, and 105 fall into the range of node 2. Right? So it's quite simple, like, and then the node 2 get chosen at the proposer for the block 50. Right? And then after that, at block 51, like, the random number is 12, and it fall into the number range of the node 1. So the node 1 get chosen as the proposer here. And then you just repeat this process until you get all of the node here. Like, so now all of the node get chosen as the proposer for this slot already. So that is quite simple, and then you just have to repeat it every span, like every time at the middle of the current span. Well, and that is all of the mechanism. Like, and what we are going to talk next is going to be the what's going to happen if the vibrator is offline or become HES. No. Like, so before we going into this topic is quite short, but just pause here first. Any question so far?
I don't have any question. I think the concept is pretty clear for me. Anyone have a question before we go to the next topic?
Also good for me. I think the concept is quite simple, and yeah, let's go to the next session, I think.
Okay, so now we know how validator got chosen as the proposer at with slot, like, and assume that we have this. What is going to happen next is that one, we reach the block 50, like, and in this case the assigned node to be the proposer is the node 2. Right? So the node 2 just have to clear the block 1. We reach block 50. Grab transaction from the pool, like from the transaction from the mem pool, like to build a block, and then broadcast block to all of the validator. And if it okay, like, so nothing going to happen, you are going to move to the next block. And one, you are going for block 50 to block 51. Now it is turn off the node 1. Like, and then the node 1 have to propose a block, but it failed to propose a block. So like I say, what is going to happen is that if it have to wait further, like, the chain is going to be stuck. Like, I mean, it is not that kind of stuck, but you have to wait for too long. So normally you have to wait only 5 seconds. In this case, maybe you have to wait 10 seconds or 20 seconds. We don't know, like, we don't know when node 1 is going to come back. So to solve this, you have the official node. Like, so the official node will kick in and then propose block 51 in place of the node 1. Right? And then once it proposes, the block 51 is just send block to all outer validator in the network. And then after that, you can trigger the slashing process to punish the node 1, like because it is the bad node. Right? And then after that, the chain just move forward, like you move to the next block. And it's the turn of the node 1 again. If the node 1 fail again, it gets punished. If it is not, it just propose block to all outer validator, and then you move to the block 50T, and so on and so forth. Like so, all in all, the concept is quite simple. Okay, so again, if you want to explore KUB Chain, like you can use this handle, and then you can search on Twitter, and then visit their website. Like, and if you already have KUB in your wallet, like, and you want to earn some yield, maybe you can try staking, like, and don't forget to stake for contribution down if you enjoy our
Yeah, I
our content. Right?
really love for this slide.
And then
Good
if
job.
you
Good
guys
job.
are and if you guys are developer, like maybe if you want again to build your own apps, like you can just explore the website and then click on the apply for GAN. But if you guys just the normal user who want to just explore the KUB Chain ecosystem, you can explore the ecosystem page and see which the app suit you guys. Maybe you may find something there. Yeah, that is all for my presentation for today. So,
Yep. Yep. Thank a lot, Phil, for your presentation. Yeah, and I think the KUB Chain is quite interesting for me. And yep, if you are the builder looking for the new opportunity to deploy your app application, I think the KUB Chain is the new market for you. Maybe you can come. And I think KUB Chain, they will release the hackathon information soon. Yep, please keep in your eye.
Yeah, I think that would be a great opportunity, right? Since like before, I think it's mostly detail, but now like they probably like there would be some program for developers to enjoy it too.
Yeah, and if you are a developer and if you have a question, yeah, please stop your comment below, comment into our Twitch thread, and yet yeah, you can send the message direct to the contribution DAO account. Yeah, I will read all the message and I will bring you to talk with the KUB Chain team directly. Yeah, and yeah, I think that is all for today. Anyone need to say something before we end up, right? Okay. Yeah. Yeah. Hi. Yeah. Again, thank a lot, Phil, for your presentation. And yep. See you next time.
yeah, bye
See
bye,
you
guys.
guys.
See you. Have a good night. Have a good day. Bye.